Hey, what's up, guys? This is Chung here again. So this time, today's daily challenge problem, right? Number 52, N queens number 2. So this one actually is very similar. It's almost the same as the N queen number 1. The only difference is that, in N queen number 1, we need to return the arrangement, right? So basically, we need to output where do we want to put that queen. This one we just need to return the numbers of this thing solution. Actually, this one is a little bit easier than the first one, in my opinion. So for n queen puzzles, right? Basically, we have n times n like board here, chessboard, and then we have n queens. So we want to place n queens at each location, at some places, so that they cannot attack to each other, right? So a queen can move horizontally, right, or vertically, or diagonal or anti-diagonal. So that's why we have to basically do a backtracking. So this one is like a very classic backtracking problem. Basically, at each of the backtracking state, we need to try to put the queen at each location that is possible, right? But there's a trick here, like I discussed in the first in the n queen number 1, you know, at each of the backtracking state, we don't have to try all the possible cells here, like let's say there's n. We basically, if that's the case, we're gonna try n squared times, right? Because since the queen can attack both horizontally and vertically, at each of the cell, we can actually, which means that for each row or each column, either one is fine. Let's say, for example, for each row, we can only have one queen, right? So which means that let's say if we place a queen on row number 1 here, it means that we don't have to worry about the row here. So which means we can simply just move the row ID downwards. In this case, instead of n square on each of the backtracking, we only need to have like n of n for loop here, which means that we can basically maintain like a row index here, I index here. It means that from 0 to I rows, we have already placed a queen. Now I'm placing the i's queen, the queen on the i's row. So that's it, right? So that's the only thing we need to be careful here. And in order to decide if this cell can be placed, we need to have like a few helper arrays, right, to help us. Since we know the current I has not been placed a queen, so we don't need like array for the rows. We only need three like status arrays. The first one is columns, so that help us to know if this column has a queen or not. The second one is the diagonals, and the last one is anti-diagonals, right? So for the diagonals and anti-diagonals, the key will be for the diagonals, the key is like I plus 1, right? Sorry, the I plus j, and the anti-diagonal, the key will be I minus j. This is like a little trick, right? So this is the diagonal, this is anti-diagonal. And yeah, so the rest is just like implementation, right? It's almost the same. So first we're gonna have like backtracking of I here. It means that if the I is equal to n, it means that we have already placed queen for each row, which means we have find arrangement. That's when we can just increase the answer by 1, right? Assuming we have a global variable, global answers here, right? And then we return the answer. Otherwise, right, we try to place a queen at the current row, right? So for j in the range of n here, and so like I said, we need a few helpers. So we have a columns, right? Columns are gonna be a length of n, right? And then we have a diagonals, gonna be the default of Boolean, because since the key for this one is like I plus j, I prefer use like dictionary. So same thing for anti-diagonal, right? We have like another dictionary with Boolean type. So here, basically, if not, if the column is not used and diagonals is not used, and same thing for the anti-diagonals, right? Basically, if all three are false, the key is I plus one, right? Sorry, not I plus j, and I minus 3. And then, and we also need like a board. Yes, you're right. So the board at the beginning, everything is actually, oh no, we don't need a board. Yeah, actually, all we need is the number of solutions. So we don't need a board. Yeah, the board is for the unqueen number 1. So we just need to mark this one to true, which means that, okay, so this column has already been used. Similarly for the diagonals, right? And this one as well. And then we do a backtrack, right? Backtrack of I plus 1, right? So now we're moving to the next one. And then next we reset the things back. So this is how backtrack works, right? So every time when we try one of the scenarios, we will basically revert this back, because remember these three are globals, right? If we don't revert it back, in the next for loop here, these values will be wrong, right? Because for each of the for loop, we should have like a clean start state. That's why we have to revert them back. And then we have the answer equal to 0, right? And then we just do a backtrack from the first one, right? And then return the answer. That's it. Oops. I guess this one, yeah. Huh. This is awkward. I'm pretty sure this should work. Backtrack 0. Did I do anything wrong here? Not this one. And not, okay. Yeah. Okay, cool. Right. And yeah, so for the time complexity, right? So we have n backtrackings, right? And each of the backtracking we have different scenarios here. So it's gonna be a n factorial, right? Because at the first one we have because at the first time, the j is starting from 0. That's why the first one is n, right? And the second backtrackings, we have n minus 1, right? And then the third one is like n minus 2, so on and so forth. That's why in the end we have n factorial. So that's the time complexity, right? Space, obviously, it's O of n, right? Because they are all sides of n. So yeah, that's it for unqueen number 2. All right. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.